Hello everybody, welcome to this video where we are going to look at conversion between canonical forms. So in the past video we have seen that there are two types of two canonical forms. One is sum of mean terms or sum of products, and the second is product of max terms or product of sums. So now in this video we'll see how we can convert from one form to the other, because as you know, every Boolean function can be represented both as sum of mean terms as well as sum of max terms. So we are going to see the conversion from sum of mean terms to product of max terms and product of max terms to sum of mean terms. So let us start with an example. So we have, let's say I have a function f on variables x, y and z. Okay, so let me write it like this: f x, y, z. I'm not going to write the extended terms, so I'll just write it in this shortcut notation: summation 1, 4, 5, 6 and 7. So this is the function. This is written in sum of products or sum of mean terms format. So this is in sum of mean terms. So this can be written as f of x, y, z as m1 plus m4 plus m5 plus m6 plus m7. Okay, now if I take the complement, what we are going to do is I'm going to take the complement of f. So when we take the complement of f, I get f dash xyz is equal to, now if you can recall, from the truth table, when we found out this, the mean terms are the ones which has a 1, and the complement of the function would be the ones which has a 0. So the complement of the function f can be written as the sum of those mean terms which are not present here. So 0 is not present, 2 is not present, 3 is not present. So, and the rest from, because it is on 3 variables, so I have from 0 to 7. So the rest all are present. So the complement of the function would be the numbers which are the mean terms which are missing from this expression. Okay, so I have f dash is equal to this. Now this can be written as m0 plus m2 plus m3. Okay, so what I have, let me just write like this: f dash is equal to this. Now take the complement of both sides. I take the complement of this, m0 plus m2 plus m3 complement. Okay, now this can be written as f complement here, f complement is equal to f. It is nothing but f. So I'll write f here is equal to what I got here, m0 plus m2 plus m3. That's right, yeah, m0 plus m2 plus m3 complement. So here I'm going to use the De Morgan's theorem, and I get m0 dash dot, plus will change to dot, m2 dash dot m3 dash. Okay, Now, isn't m0 dash any complement of the mean term, isn't it equal to the max term, corresponding max term? Okay, this is also something which we had seen earlier in our previous video. The complement of the mean term is equal to the corresponding max term. So m0 dash, small m0 dash would be equal to the max term m0. Okay, small m2 dash would be equal to the max term m2, and small m3 dash would be equal to the max term m3. So what I have now? I have this as a product of, this is nothing but a product of max terms. So from our, let me write it again using our notation, product of which terms? 0, 2 and 3. So what we started off with was this one. This is where we started off with. So f of x as sum of mean terms was given like this, and this we got here. It has been converted into the product of max terms. So this is how you can convert from max term, a mean term, to max term. The reverse is also true when you are converting from product format to sum format. So again, let me take another function f x, y, z, x, y and z. Say this is in the product of sum, product of max terms format. So product of 0, 2, 4 and 5. Okay. So again, now take the complement of f. So f complement x, y, z would be again the product of those max terms which are not present in the original. So I get 0 is there, 1 is there, 2 is there, 3 is not, 3 will be here, 4, 5. So I'm left with 6 and 7. So 1, 3, 6, 7. Okay, this is complement. Now again you take the complement of f, complement of both sides of f complement, complement of f complement. So I get f complement is equal to f. Okay, f complement is equal to complement of this whole thing, which could have been written as m1 dot m3 dot m6 dot m7. So you take the complement of this whole thing. So this side, left hand side, we get f complement is equal to f again, and this is equal to capital M1 complement, dot will change to plus, M3 complement plus M6 complement plus M7 complement, De Morgan's law. And again, from our theorem that mj dash, the complement of the max term, is equal to the equivalent mean term. So using this, I get capital M1 complement would be equal to small m1 plus m3 plus small m6 plus small m7. So this is your function which was product. Okay, let me write it using this summation symbol: 1, 3, 6 and 7. So our function, which was in product of max terms format, has now been changed to sum of mean terms format. So this is how you do the conversion.